So I'm now going to show you part B of those examples that we did before. So these ones here that we're going to look at include root functions, they include different bases, and they also bring it all together to solve for x. Okay, so this is the harder lot of the two, but we're going to start with this one up here. Okay, now the first thing we notice is that it's got that square root in it. Okay, there's actually an index law rule for dealing with that, and it's down here. Okay, it's a little bit complicated to read. All it's saying is that if it's the square root of something, didn't mean to do that, but we'll leave it there. If it's the square root of something, it is the same as x to the power of a half. Okay, if it's the cube root of something, it's the same as x to the power of a third. Okay, so whatever is, let me do this. Let me do it color coordinated for you. Whatever's up the top here, so if it's squared, okay, is the same as x to the power on the actual variable in the square root goes up the top, and whatever's out the front, it goes on the bottom of the fraction. Okay, so x to the power of a half. Usually it will only be square root or cube root. So if you can remember that square root is a half, you should be pretty okay for this one. Now, let me just find where that went. Up here. Okay, so there's a couple of ways I can do it. I can turn these into the halves first. I'm actually going to sort out the fractions first, but it doesn't matter which order you do it in. Okay, so I can see here that this fraction is being divided by that fraction. Everybody loves a bit of fraction practice. We're going to do tip and times. Okay, so the first one stays the same. The second fraction flips upside down. It's got to be the second fraction. You can't flip the first one. And it changes into a multiply. Okay, tip and times. Or you might have heard it invert and multiply as well. So then we can simplify. So we multiply fractions by multiplying the top first. So square root of a times a, and multiplying the bottom. B cubed times square root of b to the power of 8. Okay, so that's okay so far. Now we've got to sort out those roots. So remember I said the square root of anything is the same as a half. So this one here is a to the power of a half times a. Okay, I'm just going to put a little 1 there to remind me that anything that doesn't have a power is to the power of 1. Okay, I can see that those bases are the same, so I can sort them out a bit later. And down here we've got b to the power of 3 times, in brackets, b to the power of 8 to the power of a half. Okay, so whatever's inside goes in brackets, raised to the power of a half. I didn't do that one for this up here because I didn't do that for this up here. That made it worse. Because it's a 1 here, and 1 times a half is just going to be a half. Okay, so now I'm going to sort these out. So I'm multiplying, so I'm plussing the powers together. So it's a to the power of 1.5. Might just make it 1.5. Okay, or 1.5, or 3/2. And then down here, we're raising a power to another power, which means that we're timesing. So 8 times a half of 8 is 4. 3 plus 4, b to the power of 7. Okay, so that's it done. So the new skill there was turning these roots into indices. Okay, you can also go the other way. So if I had something like 16 to the power of a half, that's the same as the square root of 16, which is 4. Okay, so if you see something to the power of a fraction, you can turn it into a square root or a cube root or a quartic root, and it might make it easier for you to simplify. Okay, so you can move back and forth between those two depending on what suits you. So this one here is a bit tricky because our bases aren't the same. And if you remember from those index laws, to use pretty much any of them, the bases have to be the same. So they're not at the moment, but I can make them the same. A lot of even numbers, the first thing I'll try is 2. Okay, so you want to make the base a prime number. So 2 or 3 or 5 or 7, you want to make the base a prime number. So let's try that. Now 4 is pretty easy. I know that 2 squared is 4. So I'm going to replace the 4 with brackets with 2 squared. Okay, and the n plus 3 stays there. Now 8, I can write as 2 to the power of something as well. 2 times 2 times 2 is 8, so 2 cubed is 8. Okay, and down the bottom 16, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the power of 4 gives me 16. Okay, so I've got a little bit of simplifying to do, and then I'll sort out my fraction. So we're going to do the brackets first. So here we're raising a power to another power. So it's 2 to the power of 2 times n plus 3 times 2 to the power of 3 times n over 2 to the power of 4 times 2 minus 3n. Okay, so I'm going to distribute these brackets. So 2 to the power of 2n plus 6 times 2 to the power of 3n over 2 to the power of 4 times 2 is 8 minus 12n. Okay, so one step at a time, and if you show all your working and you go wrong somewhere, if you're very clear and you can show your understanding, those little mistakes generally won't add up too much. So remember how I said before with these fractions, you simplify the numerator first, simplify the denominator, and then start cancelling. So I'm going to do that. I've got the same base here and they're multiplying. So I'm going to add my indices. So I've got 2n plus 6 plus 3n. And I've got 2, 8 minus 12n. Okay, keep going. So 2n plus 3, and I've got some like terms up there. So 5n plus 6 and 2, 8 minus 12n. Okay, so I've got one base on the top, one base on the bottom. They are the same, so I can keep going. And I'm dividing. So remember, when we divide, we take the powers away. So I've got 2 to the power of 5n plus 6, take 8 minus 12n. Notice how I put the brackets in there. It makes it easier to distribute that negative so that we don't forget anything. Okay, and then we're going to, we've got 5, oh, I'll do it all in one step. So 5n take negative 12n would be a positive, and it will be positive 17n, plus 6 take 8 is minus 2. So that's probably as simple as I can get it. I've got it down to one base and one power. These aren't like terms, so I can't combine it. So that's my answer. Okay, so for these ones, you're not always going to get a number answer. We're getting used to that, which is okay. But just apply one index rule at a time until it gets simple. Okay, so this one's using that negative powers again. Okay, so we can see there when we've got something on the bottom like that, so 1 over or anything over a base to a power, we can rewrite that same base with a negative power. So it would look like this. I could bring the 2 to the power of 2x to the top by changing the power from a positive to a negative. Okay, and I could do the same. I could drop it back down or bring it up. Same down here with this next one. You can bring things up by making them a negative. So that makes it a bit nicer already because we don't have fractions. So the first thing I notice, I've got a base here of 2 and I don't have a base there of 2. A bit of a tip off, if they're equals, they're normally going to kind of disappear and cancel out and solve. So I know I need to make that into a base of 2. So I'm going to go through and figure out what I need to raise it to the power of. So it's a base 2 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the power of 5 is 32. Okay? Once my bases are the same, if they're equals to each other, okay, and only if they're equal to each other, you can actually drop the bases out. Okay? My year 10s do drop the base to remember it. Okay, so if everything's equal, drop the base, and we've got negative 2x equals 5. Okay, and then from there, just a little bit of algebra. Negative 5 over 2. So we're solving for x and we're going one step at a time. So that one took into account negatives, okay, which is this one here. And we dropped out the base, which is a little bit new. Okay, so that's all for that one. The next one down. Okay, again, the first thing I'm noticing is these bases are all different. So I'm going to have to change them into something that looks the same. So 5 there, that's a prime number, so that one can stay. Now I can make 25 into a base of 5, and I can probably do it with 125 too. So let's start with 25. We know 25 is 5 squared. X minus 2. That can stay there. We've got to figure out what 125 is. So starting with 5, 5 times 5 is 25, times 5 is 125, so it's 5 to the power of 3. Okay, so I've got a little bit of simplifying there, but all my bases are looking a lot better. So 5 to the power of, we're going to do it in one step here, 2 times x plus 2, so we're going like 2x minus 2. So it's 2x minus 4 over 5x plus 1. 5, so again it's like 3, 2x plus 3. So it's 6x plus 9. Okay, I can still do a little bit of simplifying. Remember, when we divide, we take away those powers. So it'd be 5 to the power of 2x minus 4, take x plus 1. Okay, I keep both sides of the equation there the whole time so I don't lose any information. So I'm going to keep going. 2x minus x is just x, minus 4 minus 1 is minus 5. Okay, all I have on both sides is the same base, so I can drop the base out. Okay, now I've got a bit of rearranging to do. So I've got more x's on this side, so I'm going to leave those alone, and I'm going to take x off this side. So that gives me 5x. Take 9 from both sides. What have I done? Negative 14. Okay, and then divide both sides by 5. And that's it. So I've got x equals. If you're really keen, you can sub that back in and check it. Otherwise, just keep going until you reach x equals. All right, so that's the end of the second half. Go and do the Year 9 practice test if you haven't already, and there's a couple of textbook questions there as well for you to practice. Good luck.